Imagine you are the logistics manager of multiple production halls. Your duty is to ensure that every machine station has all the stock it needs to work. Today is a quite busy day and everybody is requesting materials. You are trying to be everywhere and check the stock of each machine all the time. Also, you're trying your best to manage your forklifts in between in order to actually get the materials to where they're needed. Always pulling the amount of remaining stock from each station costs you a lot of time. Usually you just program a notification when stock is running low, but today you just lack the time to do so. So you just try to keep up. This is only a handcrafted example, but in many situations writing a very simple program can boost your efficiency. Sometimes the workers don't know how to program, sometimes they lack the time to create a program. Consequently, it'd be great to have a way of programming that is simple, intuitive and fast. At best, it doesn't require the use of a stationary computer or knowledge in programming. Moreover, it should be as machine independent as possible. Our solution to this is the creation of simple rules using simple and natural-like speech patterns. If you had such a system at this busy day, you could have just said out loud, if the stock is smaller than 10, then call the forklift to bring 150. And get a notification for low stock from that machine station. Since you're not pulling the remaining stock values anymore, you can focus on the coordination of your forklifts and thereby boost efficiency. Speech recognition, however, is no easy task. Recently, outsourcing of speech recognition to a distant server became popular. In our scenario, we don't want to leak any information out of the company. Consequently, the whole process must be offline and the sources should be available. With SpinPro, we have developed an offline and open source infrastructure to provide an industry-grade solution for this problem. SpinPro is a server application that receives your audio recording and pushes it through a modular pipeline for the creation of a rule. Therefore, SpinPro forwards the received audio data to an exchangeable automatic speech recognition system. This demo uses Dazer, a framework for distributed automatic speech recognition. Dazer itself forwards the audio data to so-called recognizers. Each of these recognizers performs the automatic speech recognition utilizing a predefined speech recognition framework and model. Recognizers can perform a pre-processing of the audio input. For example, one might want to use a compressor effect to decrease the dynamic range of the audio input. After all the recognizers are finished, the results are gathered in the main server. There, a combination algorithm is used to combine the recognized transcripts into one. The combination algorithm itself is exchangeable. This demo uses a two-step process of first aligning the transcripts using a progressive multiple sequence alignment algorithm and then a voting per word. The voting can be performed by a neural network as shown in current research by the IOSB, but this demo uses a simple majority vote. After the combination, Dazer returns the final transcript to SpinPro. The next step in the SpinPro pipeline is the so-called approve step. In this step, the user is asked whether the recognized transcript is correct. The user can choose to abandon the request or continue into the next step. In step 3, the actual rule creation takes place. For a user, it can be very frustrating to receive a rule created by non-deterministic algorithms. The user could receive a different result every time. We target consistent and deterministic rule creation. SpinPro has a list of keywords. A heuristic based on the occurrences of those keywords chooses a regex pattern. SpinPro checks if the transcript is matching the regex pattern and forwards the match to a so-called service. A service contains the keywords, the regex pattern, and a parsing logic. Services are developed independently of SpinPro and loaded on demand. SpinPro services are loaded from .jar archives, containing all the required resources and external libraries. Since the service must know which inputs and outputs are available, SpinPro manages all the inputs and outputs and provides them, along with reference implementations for parsing algorithms, to the services. Services also have a callback to SpinPro to ask SpinPro to parse a specific string within a pattern. This is useful for actions that contain different actions. A simple example is an if-then rule that contains actions in the then part. Additionally, SpinPro provides utility parsers for arithmetic expressions and conditions. When SpinPro succeeds to create a rule, the rule is saved into the JSON syntax as a last step. The used JSON syntax is an intermediate format that contains more meta information than needed. Some meta information is simply for statistical and identification purposes, but some of it can be used to check the compatibility of the used services for the creation of the rules with the interpreters of those. Of course, they also contain the actual rule actions in the format that is defined by the services. Some action formats like if and while are predefined. The resulting rule is saved to a predefined directory as well as sent to the client. SpinPro is designed as a framework and therefore offers a lot of modularity. Not only can the rule creation patterns or the complete automatic speech recognition components be exchanged, but the complete internal pipeline can be adapted to new use cases. Nonetheless, SpinPro always provides the client-server interaction logic as well as the code required for extensive parallelization. In short, SpinPro is a framework for exploring the use cases of automatic speech recognition in industrial environments. It is by no means a universal tool, but the modularity makes it a widely usable framework for the integration of speech recognition systems into the development. Developers can especially benefit from embedded libraries like the embedded encoding and decoding library for the efficient byte encoding of communication. An Android and a JavaScript client make SpinPro easy to use in nearly any environment. For further information on the project, please contact Friedrich Volz or Jochen Müller from the Fraunhofer IOSB.